Hi guys, today we'll discuss about random access protocol. The classes of MAC protocol are fixed assignment protocol, demand assignment protocol, random access protocol. So what is mean by random access protocol? Any station or the node can send the data at any time. So here your node or the station are uncoordinated and the protocol will operate in a fully distributed manner. We have four different classes of your random access protocol. The first one is Aloha protocol. The second protocol carrier sense multiple access. Your third protocol carrier sense multiple access collision detection. And fourth one is carrier sense multiple access collision avoidance. So first we'll discuss about Aloha protocol. Aloha protocol is a random access protocol. So here we can transmit your data in a shared medium or a channel. So this particular protocol is operated in a MAC layer and mainly designed for your wireless LAN. The two types of Aloha protocol are pure Aloha and your slaughter Aloha. So first we'll discuss about your pure Aloha. So in your pure Aloha, it's going to allow the station or the node to transmit whenever they have a data to be sent. And since there is no coordination with the other node, what happens? The protocol will accept the risk of the collision at the receiver. So this is the example for a pure Aloha. So we have a four different stations, 1, 2, 3 and 4. All these four different stations have a same shared media and we have a same time slot. So at the beginning of the time, what happened? A station 1 is transmitting a frame 1.1. So at this time, a frame will not be get collide because the remaining station is not transmitting. After a few times, what happened? Your station 3 is sending a frame 3.1. So at this duration, there is no collision because none of the station is not transmitting. So there will not be any collision. So after a few times, you can able to see the station 2 is sending a frame 2.1. So what happens? There will be a collision. Once there is a collision, now what happens? There will be a loss of your data. And after a few times, station 4 also sending and station 1 also sending. So this is called as collision duration. So during this collision duration, what happens? All the 4 station frames get collide and there will be a loss of your data in your receiver side. So to detect this, the receiver will require to send an immediate acknowledgement for properly received packet. So if the acknowledgement does not come within the time slot, then the station wait for a random amount of time. So you're going to wait for a random amount of time which is called as back off time. So you're going to wait for a random amount of time which is called as back off if your acknowledgement is not received within your allotted time slot, and then we'll retransmit your data. So why we are not giving a fixed amount of time here? No, when you are using a fixed amount of time, what happens? The collision will be get more. Our main concept is we have to reduce our collision. So we will choose a random amount of time. So when you are choosing a very random amount of time, the collision will get possibility. There is a possibility decrease in your collision. So this is the reason we are using a random amount of time. So now we'll move to your second type, which is called as slaughter Aloha. So in your slaughter Aloha, here the time is divided into time slot and the node is allowed to transmit a packet transmission only at the beginning of your slot. That is, a station is allowed to send only at the beginning of the synchronous time slot. If a station misses this moment, it must wait until the beginning of your next time slot. So we can see by using this diagram, we can discuss our slaughter Aloha. So we have 4 different stations, 1, 2, 3 and 4, and have this 4 station will share the same shared media and will use the same time limit. So you can able to see here your time is divided into slot. Slot 1, 2, 3, 4, 5, 6. So we are dividing your time into time slot. So that node is allowed to transmit a packet only at the beginning of your slot. So at the time slot 1, the station is sending a frame 1.1. So none of your station is sending, so there will not be any collision. Now what happened in middle of this time slot, the station 2 is trying to send. Now it can't able to send because the slot Aloha concept is can able to transmit a frame only at the beginning, or it can't able to transmit at the middle of your transmission. So a station 2 will wait for the next new time slot. So after getting a new time slot, you can able to see if station 2 2.1 frame, and at the same time station 3 also need to try to sending a frame 3.1. So what happens? There will be a collision. Okay, even though we are dividing the time into time slot and we are transmitting a frame at the beginning of each time slot, this will also lead a collision. Okay, so a station is allowed to send a data only at the beginning of your time slot. It leads a collision also, because there will be a possibility of a collision if two stations try to send at the beginning of the same time slot. So you can able to see here at this time slot 2, what happened? There is a collision because two station is trying to send. It leads to a collision. And in your time slot 3, your station 1 also sending, station 4 also sending. It leads to a collision. And time slot 4, only your station 2 is sending, there is no collision. 5, only station 4 is sending, no collision. And 6, since only a station 3 is sending, no collision. So the collision duration is only in the time slot 2 as well as 3, because two station is trying to send at the station frame at the beginning of this time slot. So this is about your slaughter Aloha. Thank you.